Hello students, welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. So students, first I would like to congratulate you for successful completion of the volume 1 and your term 1 exam. Right? So now, today we are going to start the volume 2. So the grade 8 volume 2 starts with a topic, a chapter called solutions, right? So now today we are going to start the solutions, right? So students, here before going to the solutions, once again briefly we check the classification of matter. Okay, so we already studied in the first volume about the what is matter and how it is classified, right? So matter is anything which has a mass and occupy the space, that is called as a matter. For example, see this pen, this is a matter, your book is a matter, my blazer, it's a matter, my specs, it's a matter. So all around you, whatever you see, those are comes under the matter, because everything what you see here, okay, they have the mass and occupy the space, they are called matter, right? And you also know that matter is classified into two types. One is based on the physical state and the second one is based on the chemical composition. This also is studied, and there we completed, mainly we focused on the physical states, right? Based on the physical states, matter are classified into three types called the solids. So matter is mainly classified into pure substances, okay, and mixtures. Okay, so here actually so matter is classified based on the physical states and the second one is chemical composition. So in the physical states, they are classified into solids, liquids and gases. So that's about the physical state, right? That is done. Now here we are going to the second type of classification, that is what based on the chemical composition. Based on the chemical composition means how that matter is made up of, right? So here based on the chemical composition, the substances or means matter is classified into two types called as a pure and impure, but instead of telling impure we can say that mixture. Okay, so what is pure? Generally you will see to go when you go to the market, you can see that so many brands will be there, like for example if you take the milk, they say that this is our pure milk, okay, this is a pure milk, this is a pure milk, so they'll say that pure, right? And so impure means what? Like adulteration, you know that, okay. So but here in the chemistry, the pure and instead of telling the impure we say the mixture, okay. So based on the chemical composition, so students, this is based on the chemical composition. Based on the chemical composition, matter is classified into two types. One is pure substance and second called the impure, or we can say that mixture, not impure, we can say the mixture. Now pure means what? Pure means what? Any matter which is made up of one type of substance, one kind of materials, one kind of molecules, okay, is called pure, okay. And again the pure substance are classified into elements and compounds. Elements means copper, gold, zinc, magnesium, oxygen, nitrogen, these are the elements. So which are made up of one type. For example, take the pure gold. We purchase the 24 carats gold. Pure gold means what? 24 carats of gold. This 24 carats of gold, okay, if you take, it consists of only gold atoms. It consists of only gold elements. No other elements are present in. It's total made up of one kind of atoms. Okay, so one kind of molecules we can say. So that is a pure. So example is elements and the compounds. Compound means what? Molecule which are made up of different elements, like water. Water is a compound, H2O. If you take the pure water, okay, so then what you can see, it consists of only H2O molecules. Water formula is what? H2O. So here all the water molecules, that water, if you are taking one glass of water, one tumbler of water, then you can see that all consist of water molecules only, all H2O, H2O, H2O only, okay, no other elements are present in that. Such substances are called pure, okay. So here elements and the compounds comes under the pure. Now what are the mixture? Mixture means what? When two or more different substances are mixed. When two or more different substances are mixed, then they are called a mixture, right? When you go to the sweet shop, then you'll ask a mixture, all varieties of will be mixed there. Okay, so that's the mixture. Mixture means what? Which consists of two or more different type of materials or particles or molecules or compounds. Okay, they are called mixtures. So these mixtures are classified into again two types, called as a homogeneous and a heterogeneous. So homogeneous means what? If we mix the two substances together, then if they mixed uniformly, okay, so then that's called homogeneous. For example, let's take one glass of water. Okay, one glass of water. Now in that add a small amount of salt. Okay, just add a small amount of salt, little amount of salt. Okay, and stir it. Then what you'll observe? The salt dissolves in water, right? So first when you add, you can see the salt particles, but on stirring, okay, then what happens? That dissolves in the water. When it dissolves, then they disappears. Yes. So after completely disappearing, now if you taste the water, okay. So for example, you say I am taking one tumbler, okay. In this tumbler, I am taking water. Right, this is a water, so this is water. Right, now in this what I'm doing, I'm adding some salt, a little amount of salt I'm adding, so little amount of salt, and then I stir it. Okay, I'll add the salt and I'll stir it. So what happens? It completely dissolves. See up, completely dissolves, still completely dissolves, you stir it. Okay, after completely dissolve, then I'll take one straw and I'll just pick up 2 drops or 2 drops of this salt water. Okay, I taste it. How the water will be? Salty. Now for example, I'll take from here just 1 or 2 drops of salt. I'll taste it. It's also salty. And if I check these two, the taste will be same. Okay, if I take some water from here, then here also the same taste I can find. I can find the same taste. Why? Because salt is completely dissolved, it is uniformly distributed throughout the water. Now, anywhere if you can see, okay, then you'll observe that the taste remains the same. So, such type of solutions are called homogeneous solutions. What they are called? Homogeneous. Now, the second type. What is the second type of solution? Second type of solution is heterogeneous. What are heterogeneous? Heterogeneous means what? The particles will not be dissolved perfectly, or the particles can be filtrated easily. They can be filtrated. For example, if you take one glass of water. Okay, one glass of water. Right. One glass of water. Now, in that, for example, this is water. In that, for example, I add soil. Soil means what? Like mud. Okay. Other than add chalk powder. Okay. You know the chalk powder? So, chalk powder. Okay. You add some chalk powder here in this water and then stir it. Then what you observe? When you stir it, it looks like it's mixing with the water. Okay. So, now water also, it turns into like a white color. Okay, actually water is colorless, it turns into like white color when you mix it, right? Now after that what you do, take this water and keep aside for some time, like maybe 10 minutes, half an hour, 1 hour, okay, whatever it may be. So keep aside for some time, right? After 1 hour or 2 hours you check, then what you'll observe? You'll observe that all the chalk particles will be settled at the bottom. Yes or no? So all the chalk particles will be settled at the bottom. So here the chalk particles will be settled, and this water, now it looks like a normal water, like transparent. Yes. Okay. So here this particles is not uniformly mixed here with each other. Okay. So this chalk powder particles are not mixing with water properly, right? So they can be easily separated. If you filter it, if you filter these two solutions, then here what happens? Here you cannot separate the salt and water. Can you separate here salt and water? You cannot separate the salt and water if you filter. Can you separate this chalk powder? Yes, you can separate. If you filter that, the chalk powder will be okay, separated from this water. So we can give this as an example for the heterogeneous. Clear to you? So that's about the homogeneous and heterogeneous. Okay. Now let us discuss in detail now. Okay. So homogeneous and heterogeneous. Again, the homogeneous are classified into two types called true solutions and alloys. Next one is suspensions and the colloids. Now, what the example I have given here? Okay. So this is a true solution. What it is? A true solution. Okay. What example here I have given? This is an example for suspension. What it is? A suspension. Okay. So suspension is an example for heterogeneous, and salt solution is an example for the true solution. Clear to you, students? So mixtures are of two types, homogeneous and heterogeneous. Homogeneous again two types called true solutions and alloys, and heterogeneous are suspensions and colloids. Okay, and alloys, you know that alloys is what the homogeneous mixture of two or more metals, or metal and sometimes non-metals also be there, that is alloys. Generally we study this in the like metals and non-metals, we study about the alloys. Okay, so in this chapter now in the solutions we are mainly going to discuss about the true solutions, suspensions and colloids, but not about the alloys. Alloys we study under a separate topic called metals and non-metals. Clear? Sure. So now what we are going to study? We are going to study about the true solutions, suspensions and colloids, right? So true solutions are part of homogeneous, suspensions are and colloids are the part of heterogeneous. Okay. So how can we distinguish with them? Okay. So see students, here on the base of particle size, remember on the base of particle size, the solutions are classified into true solutions, colloidal solutions and suspensions. So here, if you have seen here in the true solutions, here for example salt solution, can you see the salt particles after dissolving? No, you can't see the salt particles with your naked eye. Acha, okay, then what I do, I'll take one salt solution drop and I'll check in the microscope. You know microscope? Yeah, very good. So microscope. Can you see the salt particles in the microscope? Come on, guess fast. No, we can't see the salt particles even in the microscope also. Okay. So the salt particles are the powerful electronic microscopes. We may see the salt particles in the water after completely dissolved. Right. So we cannot see even in the normal microscope. So meaning is what? The size of the salt particles in the water becomes less than 10 to the power of minus 9 meters. Okay. This is called nanometer. I think you might have studied already in the physics, nanometer, micrometers, millimeters, okay, meters, everything is studied, no? So here the particle size is 10 to the power of minus 9. Okay, so normally we can see happily if our eyes are very good, okay, then you can see up to milli, means what, 10 to the power of minus 3. And if your eyes are little sharper, then you can see up to 10 to the power of minus 4. But if it is less than 10 to the power of minus 5 or something, you can't see, then you use a microscope. Okay, but these are very, okay, smaller than the microscope. So hence the particle size is in terms of 10 to the power of minus 9, right? But for example, if you take the suspension, in the middle one more type of solutions are there called colloids. But if you take the suspension, so suspension particle chalk powder, can you see? Yes, you can see the chalk powder. Okay, so when you mix in the water, so then if you keep for some time, then what happens? That will get settled down and you can see the chalk particles. So chalk particle size is bigger and they are greater than 10 to the power of minus 3. How much they are? Greater than 10 to the power of minus 3. 10 to the power of minus 3 means what? Millimeter. Greater than millimeters. Okay. Or sometimes 10 to the power of minus 4 also it will be there. Minus 4 up to minus 6. Okay. So between the ranges. Okay, right. So now let us see now. Okay. So see, a true solution is a homogeneous solution. Okay. And which contains small solid particles, okay, throughout the solute. Next you see sodium chloride, the solution of sodium chloride. Sodium chloride is nothing but a salt. It's not any chemical. It's Of course, it's a chemical, but it's normal salt. Okay, and the particle size is here. This is very important point. The particle size is less than 1 nanometer. 1 nanometer means what I say, 10 to the power of minus 9 meter. Okay, remember this, 1 nanometer. So, these particles of solute in two solutions are invisible. Invisible means what we cannot see even under the microscope, where we cannot see. Even under the microscope also we cannot see, and they can pass easily through the ordinary filter paper and through the animal membranes. Means what, we cannot filter them. We cannot separate the salt and water from the salt solution. Such a smaller particles, so such solutions are called true solutions, right? Now suspension, just now I told you that suspension is a heterogeneous mixture and which contains of small insoluble means what, which are not soluble, which are not mixing like a salt in the water. Okay, they are getting settled at the bottom. Okay, and they can be separated. So the particle size is more than 100 nanometers. More than 100 means more than 100 times of the size of the salt particles. Okay, so dirt particles in water, H2 is water. Okay, the particles of suspension may not be visible with naked eye, but visible under microscope. Sometimes they cannot be visible also, sometimes they can be visible also. Okay, so that is about the suspensions. Clear to you about the suspension? Now between the true solutions and colloidal suspension, there is one more type of solution is there, which is called as a colloidal solution. Of course, colloidal solution is also heterogeneous. Already you have seen the chart. Okay, and your example, see milk. Okay, so here the size of the solute particles is between 1 to 100 nanometers. Between 1 to 100 nanometers. Between 100 to 1000 nanometers. Means what? Greater than the true solutions particles, means bigger in size. Okay, so and smaller than the suspensions, right? So such a particles cannot be seen normally with our naked eye. However, the light reflected by them is seen under the microscope. That is called a Tyndall effect. What is that called? Tyndall effect. Okay, so the path of light we can see. The path of light we can see under these solutions, and that effect is called a Tyndall solution. We discussed that. Okay, and colloidal solution can pass through the ordinary filter paper. So to the ordinary filter paper they can move. So now see here the sizes are given here. True solution C less than 10 to the power of minus 9, which is also called 1 nanometer. Okay, and colloidal solution C are bigger than this one. So greater than 10 to the power of minus 9 to 10 to the power of minus 7. So they are bigger than, or we can say 1 nanometer to 100 nanometers, right? Suspensions you see they are greater than 10 to the power of minus 6, means what? Micro. Okay, or we can say that 1000 nanometers. Okay, so this is the particle size. So based on the size of the particles, the solutions are classified into true solutions, colloidal solutions, and suspensions. Clear, students? Chalo. Now see some other properties also there here. Nature is homogeneous. That is, true solutions is given last. So true solutions, colloidal solutions, and suspensions. So first here see a particle size. Just now we discussed it is less than 1 nanometer. This is 1 to 100 nanometers. This is greater than 1000 nanometers. Okay, and separation by using the ordinary filtration, not possible. Okay, but here you can see colloidal solutions also by using ordinary filtration it is not possible, but ultrafiltration we can separate, and here by ordinary also we can separate them, and ultra also we can separate them. So filtration is possible. Now setting of the particles. So here you can see they do not settle. Just like I said, the particles will, if you without disturbing that, if you keep aside for some time, then what happens in the suspensions, the chalk particles, they settle at the bottom. Here in the sodium chloride solution do not settle, means water two solutions do not settle. So this is only due to some special method called as a centrifugation method, and they can settle. Visibility means what can we see? So here the answer is no, these particles are invisible. Here we can see, we cannot see the particles, but we can see the scattering of light, which is called as a Tyndall effect. Here Tyndall effect is there, and here the particles can be easily visible to us. And this salt solution is transparent. Transparent means what? Through which light can pass. And here they are generally transparent. Generally they are also transparent. Sometimes they may be translucent. Translucent means what? Partially the light can pass. Okay. And these are completely opaque. Why? Because totally if the chalk particles are settling down, can you see the other side of that beaker through that particles? No, because it is totally covered with the chalk particles. So that is opaque, right? Tyndall effect, it does not show, but it shows. Diffusion means what? Mixing. Okay, mixing easily. For example, take water and if you put a salt and just a little if you shake, then what happens? It easily dissolves, right? It dissolves. Okay, so here easily the diffusion of particles takes place. Here slowly it do not diffuse. And Brownian motion. Okay, Brownian motion is not the zigzag motion of the particles in the solution is called Brownian motion. It was first observed by the scientist called Brownian, so that's why it's called as a Brownian motion. That we cannot see in the true solutions, but shows in the heterogeneous solutions. Okay, so students, these are the properties of homogeneous and heterogeneous solutions. Very important topic, very important. So you have to learn. Even it is there. You are in 8th class, right? Okay. So any doubt? Okay. Now in these three types of solutions, are there heterogeneous, homogeneous? In the heterogeneous again two types are there called colloids and suspensions, right? So here we are not going to discuss much more about the suspensions, okay, but we are going to discuss about the colloidal solution. Okay, so the colloidal solutions means what? Here also it consists of two substances, you know. So one is for example water and second one is any other substance. Okay, so two substances will be there, right? So whenever when you mix the two substances, generally one will be in the more quantity, other will be in the less quantity. Okay, for example, let's take you daily, I think you'll have a milk before going to the school or before going to bed, you'll have a milk. Yes or no? So can you drink only milk? No. You can, okay, you mix with some sugar, you mix for tasting. So your milk is more and sugar is less, right? So here generally in a solutions, one component will be more in quantity, other will be in less in quantity. Okay, so generally in the true solutions, the which is relatively more in quantity is called as a solvent, which is less in quantity is called as a solute, solvent and a solute. But when you come to the colloidal solutions, instead of calling them as a solute and solvent, we call them as a dispersed phase and a dispersion medium. Dispersed phase and a dispersion medium. So dispersed phase means what? Which is less in quantity. Dispersion medium is what? Which is large in quantity. Okay, so colloidal solutions, see colloidal solutions. Okay, so now dispersed phase. So with the component present in small proportions, little in a solution, that is called a dispersed phase. Okay, and see an example for silver in water. It's printed wrong, H2. Okay, so here H2O is water. In that you can make a, okay, take a minute particles of the silver and stir it. Okay, so now water will be more, but silver quantity will be very less, right? So here the silver is considered as a dispersed phase. Okay, and water is considered as a dispersion medium because it's more in quantity, right? Now see a dispersed medium. So generally the component present in excess means what? More. If it is more is present, then that is called as a dispersion medium. Okay, so colloidal solutions, okay, consist of two components. One is called the dispersed phase and second is called the dispersion medium, which is relatively less, that's called dispersed phase, which is relatively more, that's called dispersion medium. Okay, now classification of colloids. Colloids are also classified, okay, based on the physical state of dispersed phase and dispersion medium, nature of interaction, and the type of particles. So based on these three types are there. Okay, colloidal solutions, again they are classified into three types. Now let us see what are those three types. Okay, so based on the physical state of the dispersion phase and dispersion medium. Okay, so I said no, two particles will be there. So the two particles will be in more quantity, one is in less quantity. So which is more quantity, which is less quantity? Based on that, solutions are classified, okay, into 8 types. How many types here? 8 types. Can you see here? 8 types. Now here if you see, what are 8 types? One is dispersion phase, dispersion medium. Phase means what? Which is in less quantity. Medium is what? Which is relatively more in quantity. So solid and solid means we are taking two solids only, we are mixing. Example is what? Alloy. Already we discussed alloy. No? Alloy means what I said, the mixture of metals. Okay. For example, if you take any metal like generally we use like metals, alloys. We can take the metal which is used as a fuel. Fuse. Electric fuse. Fuse. Okay, in the physics you might have studied that to avoid from the short circuit and overloading. In such cases, we use the fuse, and this fuse will protect from the short circuit, right? So that fuse is made up of two metals called tin and lead. Okay, so here tin is in more quantity and lead is in less quantity. So like this alloys means what? A mixture of metals. Okay, so alloys, so in this both are the metals only, means both are the solid in solid. So this is called a solid sol. So how can you can say solid in solid? Yes, second one is solid in liquid, means liquid is more quantity, in that we are adding some solid, that's called solid in liquid. Example are paints, okay, starch dispersed in water, gold salt, these are example. Okay, then solid in gas, solid in less quantity, gas in more quantity, these are called aerosol because air. Okay, aerosol. And aerosol example is smoke. Okay, smoke means what? Here generally if we burn something, okay, that gives a smoke. So it's nothing but the dust particle mixing with the air. Air is in more quantity, dust particles will be less in quantity, right? So these dust particles are mixing with the large quantity of air. So the dust particles are solids, they are less, and gas is more, hence this is called aerosol. Now liquid in solid. So liquid is less quantity, solid is more quantity. Example is gel. You know the gel, even some chocolates also there, I think, no? Gel chocolates. So in that liquid will be less, but a solid will be more, right? Then liquid in liquid, these are most type of solutions we use. This one, liquid in liquid. Example, emulsions, milk, hair cream, emulsion, oils, example. And liquid in solid, liquid in less quantity, already it has come, solid. Example, aerosol. Gas in gas, both the gases. Okay, and gas in liquid. Gas in liquid means gas in less quantity, liquid is more quantity. Example is foam. Okay, so these are the 8 type of solutions are there. Okay, dispersed phase and dispersion medium. Clear? Right? Chalo. Then come to the solution. So students, here solution means you have to think, if it is only solution is given, the meaning of this one is it is true solution. Which solution? True solution. Okay, true solution is what? This one. Okay, so this I said no, salt water is an example for that. See, I have given true solution. So whenever only the word solution is asked to you, then you have to think that is not there's a true solution. Okay, so true solution. True solution, how can you define as a true solution is what? Homogeneous mixture. So we can say that a homogeneous mixture of 2 or more components. A homogeneous mixture of with 2 or more components is called as a true solution. Homogeneous mixture of 2 or more components. For example, if you take a coffee. Okay, so coffee, how can you make it? You can take the milk, you can take the sugar and coffee powder, right? These three are mixing. So here this is a solution. Okay, so 2 or more substances, if they are present, they are called solutions. Okay, if only 2 substances only are mixing, just milk and sugar. Okay, then that is only if 2 components are there, then it's called a binary solutions. What they are called? Binary solution. Binary means what? 2. Okay, so here see solution is a homogeneous mixture of 2 or more substances. Here homogeneous mixture of 2 or more substances. Okay, and here if sugar is dipped in water, so the sugar is less in quantity, called as a solid, and water is more in quantity, that is called as a solvent. Okay, and now in this we see the binary solution. Binary means what? Just want to tell you that two. If a solution is consists of only two components, okay, then that's called binary solution. So binary solution, a solution contains only two components, is known as binary solution. Okay, that consists of two components. One is solid, one is solvent. Solid is what? Which is relatively less in quantity. Solvent is what? Which is relatively more in quantity. Okay, example, solution of sugar and water. Sugar and water. So sugar and water, only two components are there. So this is a binary solution. And in that binary solution, which is relatively lesser in quantity, that is called as a solid. Which is larger in quantity, that is called as a solvent. Okay. And similarly, the solution consists of three components. That's called ternary solutions. What they are called? Ternary. Salt, sugar, and water. Okay. So salt, sugar, and water. Did you test the water in which a salt and sugar both are mixed? Yes or no? Yes? Yes. So generally, if any person is suffering with diarrhea, okay, like loose motion, something else, so at that time the person undergo the dehydration, right? So in such cases, this water is given to the patient, so to overcome that problem, right? So this is about the ternary. So ternary means what? Which consists of three components, right? And this also solutions. Two solutions are classified into 9 types, students. 9 types. How many types? 9 types. Okay. So based on the solid and solvent. Based on the solid and solvent. For example, is solvent. Okay. For example, so first we take solvent as solid. Solvent as solid. Now solid may be solid, liquid, gas. Right. So solid, liquid, solid gas. So total how many solutions? 3 types of solutions. Right. And again. Okay. If you take the solvent is liquid. Solvent is liquid, solid is solid, solid is liquid, solid is gas. So, liquid solid, liquid liquid, liquid gas. Total how many? 3 types of solutions. Then we take the gas. So, gas is a solvent and solid is solid, solid may be liquid, solid may be gas. Okay. So, gas with the solid, gas with the liquid, gas with the gas. So, like total how many? 9 types of solutions. So, see here, gaseous solutions, liquid solutions, solid solutions. Gaseous solutions is what? A solution in which gas is a solvent. In which gas is a solvent. So, this is a solvent. Okay, see here, solvent. Solvent is what in the gaseous solution? Air, gas, gas. Liquid solutions, in which a liquid is a solvent. Okay, so see, solid is what? Liquid, liquid, liquid. And third is what? Solid solutions. Means what? In which a solid is a solvent. Solvent is solid, solid, solid. Right? So, if you take the gaseous solution, solid is gas. But what will be the solute? Anything. Gas, liquid, solid. Here also, gas, liquid, solid. Here also, gas, liquid, solid. Like this, total 9 types of solutions are there. Right? Now, see here. Now, here, solid and solvent. Gas in gas. Both are gases. Then, that is example for mixture of gases. Okay? Like air. Now, liquid in gas. Liquid in gas. So, here CaCl3 is a chloroform mixed with a nitrogen gas. Chloroform is a liquid mixed with a gas. Okay. And solid in gas. Camphor in nitrogen gas. Example. Now, mostly we use this type of solutions where liquid is solvent and see here liquid and gas in liquid. Gas in liquid. Oxygen in water. You know that oxygen, aquatic animals can live in under the water. Why? Because certain amount of oxygen is dissolved. Right? Some other example, if you want to take, you can take the soda. You know the soda? Kinley, Bisleri soda will be there. Okay? When you open the soda, fizz sound will come. No? Okay? So, in that actually carbon dioxide is mixed. What is mixed? Carbon dioxide. So, that's called carbonated water. Soda is also called water, carbonated water. So, carbon dioxide is a gas, water is a liquid. So, this type of liquid in liquid, alcohol in water. Alcohol in water. Okay? And solid in liquid. So, glucose in water, sugar in water, salt in water, anything. Solid solutions. So, here solvent is solid. Gas in solid. Okay? Hydrogen absorbed on palladium. Okay? Hydrogen is a gas, you know, I think. out of 118 elements, the smallest element is hydrogen. Yes or no? So this hydrogen is a very small. So hydrogen gas, hydrogen molecules will settle in the palladium molecules, palladium atoms. Okay, so that is. Next here, liquid in solid, mercury in gold, solid in solid, metal alloys we already discussed. So these are the types of true solutions. These are the types of true solutions. In the previous slide, what we have seen, that are the types of colloidal solutions. These are what types of colloidal solutions. You have to remember, don't get confused here. Colloidal solutions. These are the types of colloidal solutions, and these are the types of true solutions. Okay, students. So that is it. And then classification of solutions based on the solute. Okay. So what is the amount of solute present in a solution? Based on that, solutions are classified into three types. How many types? Three types, called saturated, unsaturated, supersaturated. Saturated, unsaturated, supersaturated. What are saturated? A solution in which no more solute can be dissolved. A solution in which no more solute can be dissolved. For example, see students, here I have taken this 100 ml of water. Okay, I will go to the next slide. Okay, for example, I have taken one beaker. This is beaker, and I have taken 100 ml of water. 100 ml of water, or 100 grams, right? 100 grams of water. Okay, so in this, generally 100 grams of water, generally under normal temperature, room temperature, 100 grams of water can able to dissolve approximately 36.5 grams of salt in it. How much? 36.5 grams of salt in it. Okay, so if I add 36.5 grams of salt, the total salt will be dissolved. Total salt will be dissolved. Okay, now then it is called a saturated solution. What it is called? Saturated solution. Okay, now for example, if I add something extra in this one, can it dissolve? No, it cannot dissolve. Okay, so how much its capacity? Okay, so a solution in which no more solute can be dissolved. Means if I add extra, it will not be dissolved. Even I stir also, it will not dissolve. That excess part will be settled at the bottom. Right? So such type of solution is called saturated solution. What is called? Saturated solution. Okay, and if for example here its capacity is 36.5 grams. For example, I am taking 100 grams of water. 100 grams of water. In this, I am adding only 20 grams of salt. 20 grams of salt. Actually, how much its capacity? 100 grams of water has a capacity to dissolve how much salt in it? 36.5 grams. But in this, how much it is there now? Only 20 grams. Means what? It is less than required for saturation. For its saturation, how much it required? 36.5 grams. But here is how much it is there? Only 20 grams. Means less than required for saturation. So such solutions are called unsaturated. What they are called? Unsaturated. Right? So supersaturated. Third one is called supersaturated. For example, imagine that this 100 grams of water can dissolve only 36.5 grams of salt. But imagine that if it is inside 40 grams is there, 40 grams of salt is there, okay, dissolved, then that's called supersaturated. Means more than required for saturation. More than required for saturation. Okay, so that understood. No? For example, you say gulab jamun. You know the gulab jamun. Okay, gulab jamun, and that along with the gulab jamun they will give one syrup. Yes. So if you see that syrup, you know how much this how it is made up of. Here to make a syrup, almost for 1 glass of water, 1 glass of sugar will be added. 1 glass of water, 1 glass sugar will be added. Now if you take 1 glass of water and add 1 glass of sugar and try and stir it, does it dissolve completely? No, it will not dissolve completely. Okay, as long as you wish to stir it, you can stir it, but it will not be dissolved. But if you heat that water, if you heat the water, then you'll observe that the salt will be dissolved. The sugar will be dissolved. Okay, so the amount of sugar normally, how much it should be present in normal water? more than that it is present in that syrup, because we are heated that. Okay, so such type of solution in which more than required for saturation, such type of solutions are called supersaturated solution. Okay, so saturated solution means what? No more solute can be dissolved. No more solute can be dissolved. Unsaturated means what? Unsaturated means what? In which more solute can be dissolved. More solvent can be dissolved means what? That less amount of solute is there. Supersaturated means what? More solute is already dissolved, more than required. That's called the supersaturated solutions, right? In simple, if you would like to say, normally when, okay, normally, okay, whatever the in your at your home, your mom prepare the lunch every day, okay. But you think you like some special curry, you think, okay. For example, you love some, which vegetable will you love to eat? Potato. Most of the children like potato, right? So if your mom prepare the potato curry, nice potato curry, okay, then how much you eat? How much your stomach full you eat, right? And next day, for example, you think mom is prepared like a bitter gourd. Bitter gourd, you know, kakarkai. Okay, so she prepared such a curry. You think, do you eat the full of your stomach? No, you don't eat. You just eat something, and you says, "Mom, my stomach is full." So that is unsaturated, right? For example, you think your parents are taking you to a very good restaurant where Hyderabadi biryani is there. You think, okay, so how much will you eat? You eat a little more than how much you can eat regularly. Okay, so that's called supersaturated. Is this clear to you? So that is the example. Okay, but you don't write in the examination the rest, right? Now, based on the solutions also classified into two types called the dilute solutions and the concentrated. Students, you might have studied, you might have seen in your science lab, right? So if you go to the science lab, there are two types of acids, two types of bases will be there. Did you observe? Concentrated acids and dilute acids, concentrated base and dilute bases. Okay, of course both are little harmful to us, but even though when you go to the lab, your teachers will caution you, like those are concentrated acids, don't touch that, don't move there. Why? Because they are very strong, in which the quantity of water is less. Such type of solutions are called concentrated. So concentrated acid means water, acid quantity is more, water quantity is less. Very dangerous, right? So they are called concentrated. What are the dilute acids? Acids in which more water is there. Amount of water is more, but acid is less. Still they are acids, so they are called diluted. Diluted means what? In which the amount of water is more. Okay, so here others like this also you can see a solution containing relatively small quantity of solute is called a dilute, which contains relatively large quantity of solute, they are called a concentrated. So these are the types of solutions we discussed. Okay, so with this we stop today's student, and in the next class we discuss about the solubility. Okay, solubility, very important topic, the solubility. So solubility is the next topic we discuss in the next class. Okay, until take care and keep on studying. Okay, don't miss the classes.